Hello, it's Jim from JetsonHacks.com. Today we are going to work on packaging OpenCV for the Jetson TX development kits. Let's get started. One of the features that we have added recently to the Build OpenCV scripts is the ability to compile from external media. Before we get started, let us prepare a USB flash drive. I have here a little USB thumb drive. Let's use that today. Recently, I have been enjoying using the Samsung T5 portable SSDs. You can plug those into a USB port. But in this case, I'll just use this little thumb drive. I will leave a link in the description below for both the thumb drive and the Samsung T5. Plug our USB drive in. Let's format our drive. This is important. It gets all confused if you just leave it stock. We will call him Jetson TX2 and make sure we call this compatible with Linux systems, ext4. Format. The world is about to end. Format. On the JetsonHacks account on GitHub, there is a repository named Build OpenCV TX2. If you are going to be building on the Jetson TX1, there is a repository named Build OpenCV TX1. We are on a TX2 today, so let's use this repository. We are going to clone the repository. And then switch over to the repositories directory. You should note that for most of these repositories, there are releases that are associated with these videos. Take a look at the releases. For example, this one is OpenCV 3.4 Jetson TX2 version 2.1. When you're watching the videos, you can go back and figure out which release that you need for your particular setup. Okay, we have added a couple of features here. One is the ability to set a source directory where we will actually store our source code and build from, and the install directory where we will actually install the binaries. We added that feature to the Build OpenCV script. We have also created a new build and package OpenCV script. Let's go through that. One of the nice features of the OpenCV build system is the ability to actually package a system. To do that, we use CPAC. So we say, set our CPAC binary deb flag on. And at the end of the process, after we build and install OpenCV, we do this sudo make package, and it will build the packages for us. The packaging comes in a couple of different flavors. One is .deb files, another one is a compressed file, and then there is a script file. So let's build and package. Let's see what the command is. So basically we say build and package. And then the next parameter that we are going to pass it is where to actually store the source code. We are going to store that on our SSD that we just added. The install directory will default to /user/local. So let's get started. This takes a while. Build complete. Okay, our build is finished. Close the system monitor for the moment. As we talked about, what happens is when we build the packages, they are in the OpenCV build directory. Let's take a look at those. Build. Let's view this as a list. And here they are. So it's these little guys right here. Here are the three .deb files. One is the OpenCV libraries, one is the dev files, and one is the Python linkings. We also have these in a tar file. Let's take a look at the innards. Here are all the files that it builds. Here are the bins, the includes, library files, including the Python bindings and the package config, and a little bit of share files. If you want to do a manual install, that's how you go about doing it. And we also have a shell file that will install the files that we just went over. That's this little guy. So typically you take these and you'd save them off somewhere so that you do not have to build OpenCV again. One of the things that we have not discussed is the OpenCV configuration. Let's take a look at that. As we discussed, we turned on the CPAC build, but we also have CUDA on, our fast math is on with QBLAS, video for Linux is on, GStreamer 1.0 is on, and OpenGL support. Let's take a quick sanity check to make sure our build is correct. We'll go over to the examples folder. And we will run our little canny detection program. I have my stripy shirt on. Let's see what happens. 0 is the built-in camera and 1 is the webcam that I have attached. There I am. So it seems pretty happy. And you know what time it is. In the next video, we will install the package. See you soon.